All right, so this is section 17.2, and we are going to record just the notes, and then we'll have a separate video for the problems. All right, and this is about partial derivatives. And this little box I've kind of written in big language here. So what you're going to see is a different terminology. It doesn't just say f of xy, because f of xy means you're plugging in xy. What this is, f and a subscript x of xy means the partial derivative of f with respect to x. When you take it with respect to x, y is considered a constant. Kind of like when we did implicit differentiation and we just had to take it with respect to another variable, we're having to do this a little bit differently. If you have f subscript y of xy, that's the partial derivative of f with respect to y, and x is a constant. So you're going to be taking derivatives the way you know how, but when you see one letter that's going to be like a constant, you got to remember, what's the derivative of a constant? 0. But we just have to think about that. It's going to be a little different. Okay. It won't always be that it is 0. If you had y by itself, the derivative of that would be 0. But if you had 3x, what's the derivative of 3x? 3. So you've got to keep that in mind when we see something like 3xy. What's the derivative of 3xy with respect to x? 3y, because the y is just like another number that's connected to the 3. So that's going to be the difference here. All right, so let's do this one. Here's your function. F of xy equals 4x squared minus 9xy plus 6y cubed. And we're asked to find fx of xy. So that tells me that we're going to treat y as a constant, because we're taking the derivative with respect to x only. All right, so the derivative of 4x squared is 8x. The derivative of minus 9xy, remember y is like a number attached to the 9, so that's going to be minus 9y. And then we have plus 6y cubed. When you have y by itself and you're treating it as a constant, what's the derivative of a constant? 0. So you have 8x minus 9y plus 0, which ends up being just 8x minus 9y. That's the answer. That is the derivative with respect to x. The only part that's really tricky on that is when you have both of them in here like a product, and you just have to remember that y is a number, so it stays attached to 9. Okay. It went away because what's the derivative of 9x if you're doing just regular derivatives with 9? So the x went away and we're left with negative 9y. Is just like one big constant. So the derivative is 0. All right, now let's find fy, which is the derivative with respect to y. And so x is going to be a constant. So if x is a constant, let's look up here at our original. What does this thing become? 0. And then we have minus 9xy, and if x is a constant, the derivative is just negative 9x. And then plus 6y cubed, what's that going to be? 18y squared. So we have negative 9x plus 18y squared. It's not a difficult procedure, it's just you have to get used to it. You have to think about which one you're doing. Questions so far? Okay. All right. Now, we're going to have to evaluate some partial derivatives. So here's the function that we're given. So you might want to just write this down because we're going to use it. F of xy is 2x squared plus 3xy cubed plus 2y plus 5. All right. We're going to find fx of negative 1, 2. So we're evaluating this derivative at a particular place. So we have to first find fx. And if we're doing that, remember, what does that mean? It means y is a constant. So the derivative of 2x squared is 4x. The derivative of 3xy cubed, remember that the y is a constant, so that's going to be 3y cubed. The derivative of 2y, if y is a constant, 0. And the derivative of 5, 0. So the only two terms that we end up with are the 4x and the 3y cubed. Questions so far about getting to here? John, question? Mm-hmm. That's why this isn't, yeah, yeah, yeah. And it might be helpful for you to, go through and say, oh, here's a constant, here's a constant, here's a constant. And that might be helpful, but you do have to remember that that constant's attached to this 3. And so if you're taking the derivative of 3x, you do get left with the 3, but that's going to hang on there. Okay? All right, and so then you just plug in x and y values that you were given to your derivative that you just found, and you get a value. So just like when we did math 8 on our calculator to evaluate a derivative at a particular point, can't do that on here, but that's what we always came up with, a value. That's what we're coming up here. We're evaluating a partial derivative. Okay? All right, so now you find fy. That means the derivative with respect to y, this same thing, and x is going to be your constant. I'm going to get this yellow stuff off. Okay, so x is going to be your constant, and we've got to come up with the derivative of this thing. Where are the two places that you get 0? 2x squared and 5. So those two are gone. Then we got to think about this guy, the 3xy cubed. All right, so 3 times 3 is 9, because we're taking the derivative with respect to y. So 9y squared, but the x is attached there, so 9xy squared, because that's just a constant. The 3x is a constant. So think about, you're multiplying 3 times this constant. If you just had, because there's no y here. So this whole thing is just a constant, and the derivative of a constant is 0. Now, over here, let me just think about something, or let you think about something. Looking at this guy here, if we wrote just 3y cubed, what would be the derivative if we're just taking the derivative with respect to y? That'd be 9y squared. All right? Well, we've got 3xy cubed, and think this is just a constant. So you're going to say 3 times 3x is 9x y squared. Better? It's just going to take a little time to think about it. So you should get 9x squared xy squared plus, and the derivative of 2y is 2. And then you'll plug in, and you should get negative 322. Okay. Any other questions on that? All right, so those are first order. That's like if you were just taking the plain old derivative of something with respect to x or something with respect to y. Then we have second order partial derivatives. Okay? Maybe this would this be a good place to? Okay, so we're going to save this for the next video, and we will start with this because this is a long process, and we've kind of gotten a good bit of stuff already.